Good evening, everyone. So today's class, I am here to explain about the topic simulation-based testing method for liquid limit analysis of soil. So this is one of the demo model method of teaching without using any equipment, using simulation in the form of virtual labs. So our objective in today's class is to conduct liquid limit experiment without using any equipment by means of simulation. So before going into the topic, I have already taught you what liquid limit is, and Janika can explain what is liquid limit of soil.
Liquid limit is defined as the arbitrary limit of water content at which the soil is about to pass from the plastic state into the liquid state.
So this is the boundary water content between plastic state and liquid state. A particular boundary water content is defined as the liquid limit of soil. So shall we go to the simulation? So this is how the simulation works. You have to take the container first, and then you have to fill in the soil sample. You have to add certain amount of water to the soil sample, and the apparatus mix. So we are mixing the water with the soil, and the apparatus, Casagrande apparatus, is made available in the form of simulation. So we have to mix the soil. We have to fill the soil with the bowl, which is present in the Casagrande apparatus. Okay. After that, we are giving by number of blows to the soil. We are making a groove of 1.2 centimeter or 12 mm. The size of the groove is 1.2 centimeter. So as previously told, liquid limit is the water content corresponding to 25 number of flows. So we are adding water to particular amount of soil. So we are making a groove of 1.2 centimeter. We are giving number of flows and recording the number of flows at which it is required to join the groove of size 1.2 centimeter. So you just rotate. On giving the number of flows or vibration, the groove begins to fall down due to shear strength, and finally the groove is joined and the readings are noted. Similarly, the experiment is repeated for several trials upon addition of different amount of water. Say for example, if you take 100 grams of soil, you just start with 20% of water. For that, you will be getting corresponding blows as 50 blows required to join a groove of 1.2 centimeter. Gradually, you increase the water content. The number of blows required to join the groove will be minimized upon addition of water content. So, if you start increasing the water content, the number of blows will get reduced, and finally it becomes, for example, it starts from 50. From 50 it is reduced to 40, 30, 20, and finally number of blows becomes to 9 upon addition of water content. Initially you have taken 20% of water content, and after that 20 you are increasing by 5%, 25, 30, 25, 40 or 45%. In this case, in this trial, based on simulation result, what we infer is we have taken water content from 0, 5, 10, 15, 20, 25, 30 and 25%. The corresponding number of blows required to join the groove is plotted along x-axis. Water content along y-axis, and number of drops or number of blows required to close the groove along the x-axis. So the readings observed are for a water content of 24.49%, the number of blows required was 30. If you increase the water content, the number of flows is gradually decreasing. So upon adding 25.59% of water, number of flows required is reduced to 26. On further addition, for a value of 28.21% of water content, we have received the number of flows as 22%. On further addition to 31.75%, the number of flows is gradually decreased to 15%. As far as liquid limit is concerned, the number of flows corresponding to 25, the water content corresponding to 25 flows is considered to be the liquid limit. So here the value is for 26, the water content is 25.59. have plotted the graph, you obtain the liquid limit value. Say for example, for 25, you will be getting the liquid limit as 26.24%. So in this case, the liquid limit value is 26.24%. So it is between 22 and 26. So thank you for listening to this video. I hope this virtual lab method of teaching would be helpful for you to understand the concept better. It saves time because conduction of real-time experiment takes more amount of time when compared with this kind of experiment. I hope this video is found useful to you. Thank you for listening to this video. Have a good day.